Advanced Calculus, Vector Functions, Session 2. We shall be looking at the limit of vector functions. For a vector valued function r of t, which is defined as f of t, g of t, and h of t, the limit of the function as t approaches a is given by lim f of t, g of t, h of t as t approaches a will be the limit of the individual component function. So lim f of t as t approaches a, and lim g of t as t approaches a, and lim h of t as t approaches a, provided all the indicated limit exists. So if any of the limit indicated on the right hand side, that is here, any of the limit here does not exist, then the entire limit for the vector function too does not exist. So when we are asked to find the limit of any vector function, we zoom into the individual component functions and find the limit of the individual component functions. If any of them fail to exist, then the entire limit of the vector function also does not exist. Let's look at the first question. We have to find the limit of this vector function, which is defined as 1 plus t cubed I t e exponent negative t j and sine t over t k. So we'll find the limit of the individual component functions. Lim 1 plus t cubed as t approaches 0 will just be 1 plus 0 cube, which will yield 1. Then the limit of t e exponent negative t as t approaches 0 will be 0 into e exponent 0, which will yield 0. Then lim sine t over t as t approaches 0. This is a special case in trigonometry. When we have sine t over t as t approaches 0, the result is 1. At appropriate time, I'll do a video to explain much on the limit of trigonometry functions. But at this stage, let's just accept that the limit of sine t over t as t approaches 0 is 1. So the limit of this vector function exists because the component functions do exist. The limit of the component functions, all of them do exist. And hence the results will be 1, then 0, and then 1, which can also be written as I plus k. Remember, the j component is 0, so it can be ignored. The second question, the limit of t squared plus 1, 5 cos t, and then sine t as t approaches 0. So we'll find the limit of the individual component functions. T squared plus 1 as t approaches 0. This will be 0 squared plus 1, and this will yield 1. Then lim 5 cos t as t approaches 0. This will be 5 cos 0. And since cos 0 is 1, It therefore means that this limit will evaluate to 1. Then we'll look at the last component function, sin t. Lem sin t, as t approaches 0, will be sin 0, and sin 0 is 0. So the results will be 1, 5, then 0, or otherwise I plus 5j. Let's look at another one. Lem e exponent 2t plus 5, as t approaches 0, will be e exponent 0 plus 5, and this will yield 5. Sorry, it will yield 1 plus 5, which is 6. Then lem t squared plus 2t minus 3, as t approaches 0, will become 0 squared plus 2 into 0 minus 3, and this will yield negative 3. The last component function, lem 1 over t, as t approaches 0. As t approaches 0, 1 over t will be undefined. So this does not exist. Since one of the component functions does not exist, it therefore shows that the limit of the vector function 2 does not exist. Of the vector function does not exist. Let's look at this group of questions too. Let's pick the A. The limit of t squared minus 1 as t approaches 0 becomes 0 squared minus 1, and that is negative 1. Then lem e exponent 2t as t approaches 0 becomes e exponent 0, which is 1. And the last one, lem sin t as t approaches 0 is sin 0, which is 0. Or the limit exists. Henceforth, the limit of the vector function will be negative 1, 1, then 0. Let's look at the next one. Lem sin t over t as t approaches 0. As said earlier on, this is a special case. The value is 1. Lem cos t as t approaches 0 is equal to cos 0. And cos 0 is 1. Then the limit of the rational function t plus 1 over t minus 1 as t approaches 0 will be 0 plus 1 over 0 minus 1, and that will be negative 1. So the value of this limit is 1, 1, negative 1. And let's look at the last one. The limit of ln t as t approaches 0. As t approaches 0, ln t will be undefined, and as such, this limit does not exist. And since this does not exist, there is no need computing the limit of the remaining component function, because if one of the component function does not, the limit of one of the component function does not exist, then the limit of the entire vector function does not exist. So we can just conclude that the limit of the vector function len t, comma, square root of t squared plus 1, comma, t minus 3 does not exist. This is the end of the second session. See you in the next session, but don't forget to subscribe to my channel. Thank you.